Welcome to the Explainer. Today, we're going to absolutely demystify app performance and completely transform your sluggish, laggy code into a lightning-fast experience. How? Well, we're walking through a practical, no-nonsense triage checklist. Whether you're a junior developer just starting out or, a seasoned pro who still wrestles with a jittery UI from time to time, this Explainer is built exactly for you. We're going to dive into the real actionable habits that make apps actually feel fast. Let's get right into it.
I'm sure we've all heard this exact feedback from a project manager at some point. The app just feels laggy. Oh man, it's literally the most dreaded feedback you can get, right? There's no crash, there's no error in the terminal, no red screen of death. It's just laggy. As engineers, we totally hate that word because it's vague, it's emotional, and it completely fails to show up in our error logs. But here's the hard truth we have to face. Users feel it instantly. And once they feel that lag, we've already lost half the battle.
So today, we're tackling those performance woes with a prioritized checklist. Number 1, state and rebuilds. Number 2, layout traps and heavy assets. Number 3, smooth threads and animations. And finally, number 4, profiling and perception.
Let's kick things off with Section 1, state and rebuilds. These are our top priorities.
These are absolutely the biggest offenders that are silently killing your UI. Think about the definition of a rebuild, re-rendering a widget tree. Now, doing this to a giant tree 60 times a second is the ultimate enemy of a smooth UI. Sure, Flutter is incredibly fast under the hood, but rebuilding the entire universe just to update one single tiny value? Yeah, that's a terrible idea. If you remember literally nothing else today, remember this. Unnecessary rebuilds are public enemy number 1.
So how do we actually fix this enemy? Well, for newer developers, a super common anti-pattern is attaching a setState call to a massive widget that basically renders half the screen. When you do that, Flutter will efficiently rebuild everything below that call. The actionable fix here? Push that setState as far down the widget tree as humanly possible. Split up those large widgets. Start using ListView.builder or animated builder. If your UI is janky when you scroll or type, I can almost guarantee you this is the culprit.
And that leads us right into our next core habit, using the const keyword. Now, you might think skipping a const tag on a tiny text widget is totally harmless, right? But imagine multiplying that by, say, 300 widgets on a single screen. It literally becomes performance death by 1,000 paper cuts. Think of const as a performance contract. When you use it, those widgets are created at compile time, meaning Flutter completely skips rebuilding them. So the rule is simple. If it can be const, make it const. Period.
Here's another absolutely crucial rule of thumb. Your build method is not your playground. I constantly see developers parsing JSON, sorting lists, or formatting dates right inside the build method. But because that method can run up to 60 times a second, it should only be used to describe the UI. You've got to move that complex logic out of there. Put it in init state, stick it in your providers or your view models. Basically, if your build method feels smart, your app is going to feel incredibly dumb to the user.
Moving right along to Section 2, layout and heavy assets. Time to avoid those traps.
Going down our triage list, we really need to inspect the structural traps you might be falling into. For instance, if your list stutters when you scroll, it isn't Flutter being slow, it's your layout. A classic junior trap is using a column wrapped in a single scroll view for long content. Just don't do this. The actionable fix is to always use ListView.builder. Why? Because it only builds the items currently visible on screen, and it efficiently recycles those widgets as you scroll. It's a real game changer.
Okay, let's address a very common misunderstanding: keys. Keys are powerful for sure, but they are frequently abused. You should definitely use them when you're reordering lists or when animations depend on widget identity, but please stop worshiping keys. Adding them just in case when you don't actually understand why you're adding them. That actually causes more rebuilds, not fewer.
Next up, let's talk about the heavy digital assets weighing you down. The absolute fastest way to kill performance is images. Honestly, most performance issues eventually lead back to huge image sizes and a lack of caching. Because, look, users do not care about your stunning 4K image if you're just cramming it into a tiny 48-pixel avatar. The fixes here are super straightforward. Use cache network image, resize your images on the back end, and aggressively use cache width and cache height in your code.
Which brings us to a kinda invisible performance killer, overdraw. Overdraw is exactly what it sounds like. It's when you draw the exact same pixels multiple times on the screen, which heavily taxes the GPU. Stacking containers with colors, gradients, shadows, and opacities, it feels harmless, but it really isn't. To give your poor GPU a break, avoid unnecessary opacity widgets, reduce how much you use shadows, and prefer using a simple colored box over a container when you just need a background color.
On to Section 3,
Smooth threads and subtle animations. Let's keep it smooth.
To keep your app feeling buttery smooth, we absolutely have to keep the main thread unblocked. Remember, Dart is single-threaded by default. This means if you tap a button and trigger some heavy data parsing on the main isolate, your entire UI completely freezes. And if tapping a button freezes the UI, you've lost the user. The actionable fix is to offload that work. Use compute or set up background isolates to do all that heavy lifting behind the scenes.
Now, when it comes to animations, Flutter makes it almost too easy. But just because you can animate everything doesn't mean you should. Subtle beats fancy every single time. Try to follow these rules. Stick to animating position and opacity. Avoid animating actual layout sizes whenever possible to save on rendering time, and keep your durations short. The crucial takeaway here is this: if a user actively notices your animation, it's probably too slow.
Finally, Section 4, Profiling and Perceived Performance. How we actually measure success.
Let's shift our mindset for a second. We're moving away from the code itself to how we measure success. And we've got to start with the biggest lie in Flutter development: debug mode. Listen to me on this one. Debug mode lies to you about performance. I have seen entire teams panic over sluggishness that just completely disappears in release mode. So stop guessing. Performance guessing is exactly how bugs survive. You must use Flutter DevTools, look at your frame rendering charts, and always measure your performance in profile or release mode.
Which brings us to a really fascinating question. Does actual performance matter more than perceived performance? Here is a kind of uncomfortable truth to wrap your head around, especially as you level up from a junior to a senior developer. Your end users do not care about exact frame timings. They have no idea what a 16-millisecond frame is, and they really don't care.
Users simply care about the app feeling fast, and you can easily achieve that feeling with 3 super actionable tactics. First, implement skeleton loaders so the screen doesn't just sit there blank. Second, use optimistic UI updates, meaning update the screen as if the network request succeeded immediately while it actually processes in the background. And third, provide instant visual feedback the literal millisecond they tap a button. Mastering perceived performance through these optimistic UI tricks is arguably just as important as mastering your widget tree. As this quote perfectly summarizes, sometimes the fastest app is the one that pretends to be fast. You are managing the user's psychology just as much as you're managing the device's CPU.
I'm going to leave you with this empowering challenge. Flutter is not slow. Bad Flutter code is. If your app is sluggish, stop blaming the framework. Look at your widget tree, look at your rebuilds, your images, and your own habits. Use this checklist, fix those fundamental habits, and watch your app absolutely fly. So I have to ask, what piece of laggy code are you going to refactor first today?